All right, 2 dimensions, right? There it is. Oh, wait, I'm frozen myself. There we go. Okay, so 3 variables, we're going to add a z. Where do you think z would be? If I have x, y, where's there room for z?
At the bottom?
Yeah, kind of, z's going to be coming out at you. So that adds like a 3rd dimension, right? Kind of crazy. Okay, you don't have to copy this down. This is for visual purposes.
Oh my god.
So an equation in 3 variables, think about this. Think about this. A line is technically like 2 dimensions, right? You have an x and y. What are these? People who pass geometry, these aren't lines. What are these things?
Planes.
They're planes, right? That's what 3 variables is going to generate a plane. Here's an example of an inconsistent system. So 3 planes that are not touching each other. All 3 at one time. Tiffany, put your phone away. Right? Okay. Even though these are meeting, they're not meeting all at once. All right. What about this one? How many places are those meeting? If you can kind of visualize the 3 dimensions there. What are they meeting at?
They're meeting in the center.
Okay, yeah.
They're meeting in the
sure.
center. And
But it's meeting at like a point, right? Okay, but bear with me on this. It's a point, but it's like a sphere almost, right? Like a point on your paper is like 2-dimensional, but this is like 3-dimensional. So even that point has an x and a y, but it also has a z. It has a depth. So instead of it being called an ordered pair, okay, let's logic our way through this. Instead of the solution being an ordered pair, the solution here would be called an ordered, what's the word that you use for a group of 3 things?
Trio.
Ordered trio. That sounds better, but it's really called an ordered triple, okay? So instead of our solution being just x, y, our solution now is going to be an x, y, and then z. You don't have to write this down. No, I'm just, if you could draw that, that's amazing, but you don't have to draw it, okay? So that would be a consistent independent system because there's one x, y, z where all of those are meeting. And then look at this one. Here's your consistent dependent. See how are those meeting? They're not meeting at a point. How are they meeting? At a line. So they have an infinite number of solutions, and the solution would be every ordered triple on that line. Now look, we're not going to get that deep in Algebra 2. College math, sure. You could go and you could solve these. And I would never ask you to graph these, okay? We're just going to figure out through substitution and elimination how to get this ordered triple, okay? So here's our first example. And we have P, Q, and R instead of X, Y, and Z, but it would function the same. So take a second, write that down. I'm also like 98% certain that every single person in this room could solve that, by the way, without me teaching you how to do it. As you're writing it down, I bet you can figure out how to do it.
Solve that?
Yeah, I'm pretty sure everyone could do that. I'm sure everyone could figure out Q and R and P. Because one of them's given to you already, right?
Yeah, Q.
Yeah. So if you got Q, how could you figure out R? You guys see it? We're just going to substitute. We're going to get one value. We're going to plug it in to get another. We're going to plug that in to get another one. Okay? Don't be afraid. This isn't that bad. Okay? All right. Well, we know one answer, right? We know that Q equals -8. So we're going to go up one level. And we're going to plug in that -8 into Q. And we're going to find R. Why couldn't I go straight to the top, though? Why can't I?
Because we don't know R.
Exactly. We don't know R. We have to get one at a time, and then we can get to the top. So now I'm going to find R. Find R. So R plus 2 times -8, because Q is -8, right? Equals -13. So R, 2 times -8, -16, equals -13. We add 16, we add 16. So R equals 3. Right? Sorry, I wasn't showing this. Plus 16 plus 16. -13 plus 16 is 3.
R equals 3.
R is 3. So now we know Q, now we know R. Can we find P? Yes, we just plug it in. This is substitution. Okay, so now I'm going to find P. Plug all that in. So I don't know P, it remains P, minus 3 times Q, so 3 times -8, minus 5 times R, which is 3, equals 7. Okay, something like this, you really got to make sure you know your order of operations, right? You got to multiply before you can add and subtract. So, this will be P. -3 times -8 is positive 24, so plus 24. And then -5 times 3 is minus 15. Equals 7. And then we just simplify that. 24 minus 15, what is 9, right? P plus 9 equals 7. Looks like I wrote a Q there. That's the number 9. Okay? And then we minus 9. P is -2. And to verify, we can plug in everything to make sure it all works. Here we go. All right. We have to express our answer as an ordered triple. Okay? Now, we don't have X, Y, and Z. We have different letters. So when you have different letters, you are just going to write your ordered triple in alphabetical order. So you got to sing the alphabet in your head if you need to. What letter comes first in all of that? P. P. So P comes first, -2. Then Q. Q, R, S, T, U, V. Right? Q, which is -8. And then R, which is 3. P, Q, R. And that would be how you express your solution. Ordered triple. That's not so bad, right?
I mean, no.
No?
I'm waiting for your voice.
Okay. Let's do another one. Now we have X, Y, and Z. I'm going to let you do this one, and I'll come around and check. Okay? I'm pretty sure you don't need me to do this one with you. I'm pretty sure we can handle this one, right? The hardest it gets is arithmetic, and you have a calculator, which I will never take from you. So when in doubt, just punch it in there, okay? Just like the last one. Start at the bottom, work your way up. So it'll be kind of like you did the parentheses, so you do 2 parentheses 3. Yep. That's right. That's right, yep.
Okay, I didn't finish.
That's a negative 11. So you have to use so that's a negative 11. That's going to change things. So FYI, not that you can't have fractions. There are no fractions in this one. The answers will be integers. Yeah, that'll be a negative 34. Negative 20. Okay, now the 2 is positive. Negative 9, negative 11 minus 9.
Yeah. Sorry. I used to have a funny one.
Yeah, that's why. And then you would just plug in negative 10 for y up here. Here and solve it again. Right, that means both y. So that would be negative 40. And then that would be 6, right? Because you use 30. Okay. So I think I checked just about everyone's, but yes, we got that?
Yes.
Okay. That stuff's on your test, your next test. So if you can do that, you got a couple questions on your next test of that. So if you can handle that, and you have time to practice because we have a homework, right?
Is this what elimination too?
We're about to do elimination. Next test is next Tuesday. All right, now look. These are the last two. What did you notice about their setup? They're kind of like upside down pyramids, right? You have an answer at the bottom, then you go back up, and they're not full systems, right? Well, of course that exists, right? So we're going to try that now. There's a full system, okay? We're going to solve with elimination. All right? So here's what I need you to do. Copy this down. The neater you can copy that down, the better. Then maybe like stretch for a second. Get ready to feel like a genius. Because we're going to do some math and we're going to feel like a genius, okay? So you're ready for that. Why haven't it's mine?
Are you still recording?
I can't figure it out.
Why are you here? She's going to hear yourself say that.
Mm-hmm.
I don't know why.
Okay.
Are you still recording?
Oh yeah. Oops.
You're going to hear yourself say that. We were just waiting for it.
It is what it is.
Well, what if she doesn't cut it out? Not. She cuts anything.
Okay.
Well, they can cut some.
Elimination. We are going to choose. All right, you ready? Wait, you can't sleep on this. This is important stuff. We're about to be geniuses. You ready? Genius. Okay? We're going to be geniuses. Okay, now look. We want to get rid of X, Y, or Z. Okay? We have to make a choice. Everyone thinks they like choices, but when actually faced to make a choice, we don't like to do that. But we're going to make a choice. What do we want to eliminate, X, Y, or Z? Well, you can make any choice. But one of those might be a little easier. What do you think might be easier to eliminate?
Z.
Z?
Or X. Or Y. No,
I'm going to be honest. All three of them are probably pretty okay to eliminate. I'm drawn to Y. Here's why I'm drawn to Y. First of all, I see that this one has a coefficient of 1, which I know that X and Z do as well. But it's negative, and these two are positive. So don't I need a zero pair to make something eliminate? Well, if I'm going to eliminate Y, I've got one that's already negative. Whereas with X and Z, I would have to change the sign at some point. Does that make sense? Okay, but it doesn't matter. So I'm going to choose Y, and I'm going to pick two equations. to eliminate y with. I'm just going to pick 2. Does not matter how you do it. I'm going to pick these 2 because can't I eliminate y pretty easily if I pick these 2 equations?
Yeah.
Can we all kind of see that? As long as we practice what we learned yesterday, we should be able to see that, right? What would we multiply the third row by so that we can eliminate our y? 2, right? Because if I multiply this by 2, that turns this y into a negative 2y. That's a positive 2y. We have elimination. So I'm going to take these 2, and I'm going to multiply the third row by 2. So what we do is we kind of go, I'm going to go off to the side, and I'm just going to write these 2. So I'm borrowing the second equation, which I'm not changing. X plus 2y plus z equals 3. And then I'm going to take the third row times 2. Everything times 2, right? So 4x minus 2y plus 4z equals 2. Okay. Then we're going to add those together. We're going to combine them together. Okay? So we're left with 5x.
Yes, I'm confused. Why didn't we put a doing thing to the one in the middle?
Because we didn't need to. I'm just choosing 2 equations.
Oh, you don't have to do.
I'm ignoring that top one right now. I'm just picking 2. And it's totally a choice. Okay? I know that's hard because we want to follow one method, but there is some choice involved. And as you practice, you get better at making easier choices. I'm telling you the choice we're going to take right now. All right. So y's were eliminated. That's the goal, right? And then I have 5z equals 5. So I just picked 2 equations to eliminate y. I chose y to eliminate, and then I just picked 2. Okay? I know we ignored that top equation. It's okay. We're going to give it some attention right now. Okay? We didn't use the top equation. So now I need to do this again. Well, this is just sitting here. This 5x plus 5z equals 5 just sits there for a minute. I need to use that top equation, and I need to eliminate y as well. Okay? Which other equation is going to help me to eliminate that y? The second one or the third one?
The
third one. Because I would just have to multiply this by what? 3. Because that would make a negative 3y and a positive 3y, which makes my 0 pair. If I pick the middle one, I'd have to make them both into 6, right? Which I don't want to do. All right, so I'm going to take the top one and the third one times, and the bottom one's going to be multiplied by 3. So I go off to the side. I'm going to go on this side now, and I'm going to write the top equation, 6x plus 3y plus 4z equals 3. And then I'm going to take the third row times 3. So 6x minus 3y plus 6z equals 3. Alright? And then add those together. Okay? Okay. Add those together, see what we're left with. 12x. Our y's cancel out. Plus 10z equals 3 plus 3 is 6. Okay. You kind of see what we set up here? Now we have 2 equations just in x and z. So what we do now is we bring those 2 together and we make a system out of those 2. So I have 5x plus 5z equals 5 and 12x plus 10z equals 6. And now this becomes like a problem from the homework that we did yesterday. Okay? This is now just a 2 by 2, a system in 2 variables. I know we killed off y, but it'll come back at the very end. Okay? It'll come back. Okay? We'll find it. All right. If we're looking at these 2 now, what are we going to eliminate? X or Z? There's a clear, obvious winner here. Which one? Z, right? Because I can make 5 into 10. I don't want to generate 60, right? I don't want to do that. So we'll take our top and we'll multiply it by what? 2. We have a positive 10. I want to make that one negative. So I'm going to multiply it by negative 2. So I'm going to go off over here and rewrite that. So that makes negative 10x minus 10z equals negative 10. And then I'm not changing the bottom one, so I'm bringing it over as 12x plus 10z equals 6. Adding those together. And let's see what we get, right? So we eliminated z. We have 2x equals negative 4. Divide by 2. What is x?
2.
Negative 4 divided by 2 is negative 2. All right, we have x. Yay! Which variable are we able to figure out next from substituting? Remember, just like the other problems, go up one level. Right? Well, so one level where I'm looking at x's and z's, right? Because now it's kind of set up like those pyramid ones. I have x, now I can find a z. So I just choose one of these equations to plug in for x. I'm going to find z. How about we use this one, smaller numbers, right? So 5 times x, and x is negative 3, plus 5 times z equals 5. Okay. 5 times negative 2 is negative 10, plus 5z equals 5. Add 10. 5z equals 15. So what is z? 3. Z is 3. Oops. Z equals 3. Okay, we have z, we have x. All we need now is y. So we go to the top level, right? So we go all the way up here, and we're going to pick one of the original equations to plug in to find y. Which one looks like it's going to be easier?
The smallest one.
Smallest one. So maybe the middle equation, just because it has looks like math is easier to do. Okay. So I'm gonna do that off to the side here, so I don't have to keep scrolling. So x was, what was x? I forgot. Negative 2. All right. So I'm plugging into the second equation, so that would be negative 2 plus 2y. I don't know what y is, so it just stays y. Plus z, which was 3, right? Equals 3. So I'm just taking the second equation and I'm plugging in the x I found and the z I found. And simplifying. So on this side of the equation I have negative 2 and 3, which makes 1. So I have 2y plus 1 equals 3. Subtract 1. 2y equals 2. Divide by 2. Divide by 2. So y equals what? 1. All right, we have our answer. We have x, we have y, we have z. Only thing left to do, put it inside of a fancy order triple solution set. Solution is the point, negative 2. Next would be y, which was, I instantly forgot. What was y? 1, okay. And z, which is 3. And you have an answer. You figured it out. Did y'all realize that day we did the review for the last test, and you were over here with those pictures? That is exactly what this is, but instead of cheeseburgers and flowers, it's X, Y, and Z. You did this. Every single step of this you did, but when it was a picture, it was fun, and now when it's numbers, you're like, ugh. But it's the same thing. You did it before I even taught it to you. So don't feel like this is that hard. You can do this, okay? All right, let's do one more. Any questions I can answer about this one? No. Before we just try this process again? No? Okay. Whoops, yep, too far. All right, let's try this one. So take a second, copy that down. Make sure you get all the negatives in the right place, okay? Make sure you're copying that down correctly. this, your first step is always a choice. Okay? It's a choice. And you can't make a wrong decision, unlike life, where you can make lots of wrong decisions. Here, you can't make a wrong decision. Okay? If you choose X, then you'd have to, you'd have to make these into each other, right? So I've got an 8, so I would eventually have to make something be 8. I could choose Y. All right, I like Y because it's got a coefficient of 1, or it could be Z. It could be anything. When I'm making my choice, I look vertically, and I look at what has the smallest coefficients. So like X has 8 and 4, right? Y has 2, 3, and 1. Z has 6 and 2 and 1. I would probably pick Y just because it has the smaller numbers. Okay, but you can do whatever you want. All right, so if we do Y, okay, what 2 do we want to do first? Someone just make a decision for us. Which 2 equations should we use first to get Y by itself? I would choose the last one in the middle too. Yep. Right? Okay, so if I choose row 2 and I'm going to call them row numbers. Row 2 and row 3. I would have to multiply row 3 by what to make that 0 pair? Positive 2. Because this one's already a negative 2. Multiply that by 2, I've got 2y. Yes? Okay. So, but I can't just do that. I have to do the entire equation. So I'm going to rewrite these two. So I've got x minus 2y minus z equals 2. And then twice this entire last row. So 8x plus 2y minus 4z equals negative 8. Just got to make sure you multiply that entire row. And then add them together. See what we got. 9x minus 5z equals 2 minus 8, negative 6. Okay? All right. Now, it feels like you want to do more here, but you can't. You can't solve this. There's 2 variables in it. You move on. You're done with that. Now you got to go and you got to pick out that other equation we didn't use, which was row 1. Okay? And we're going to combine this one. Remember, we're trying to eliminate y here. So which row should I use to help me do that? Yeah. Okay? Because I can change y into whatever I need it to be. And I want it to be a negative 3, right? Okay, so I'm going to multiply it by negative 3. Because that will make negative 3y, and that one's a 3y. So we write the top, 8x plus 3y minus 6z equals 4. And I have negative 3 times the last row. So negative 12x minus 3y plus 6z equals 12. And you add those together. Something really awesome happens when you add those together. Has anyone figured it out as you're doing it? You get a bonus in this one. Big bonus. See what it is? Negative 4x, right? Y's are eliminated, and look at that. Z's are eliminated too. We weren't even trying to eliminate z, and it happened. Equals 16. So look, you can solve for x. There's no need to make that second group of elimination here. We don't have to do it, because we can figure out x. What is x? X equals negative 4. Great. I have one of my answers. I have 1/3 of the answer, right? I can go right back over now. Now what's the next variable I can get? Z. So I go right back over here, and I'm going to find z. And I only have one equation I can pick from. I have only one equation I can use. I'm going to find z. So I plug in negative 4 for x, so 9 times negative 4 minus 5z equals negative 6. 9 times negative 4 is negative 36 minus 5z equals negative 6. 6 plus 36 is 30. So what's Z? -6. Be really careful with the positives and negatives. If I put 6 there, is that the same thing? No, it's like the exact complete opposite, right? Okay. All right. Get Y. Plug it in, get Y. We got -4 for X. We got -6 for Z. Let's get Y. Let's see, what do I want to plug into? What equation looks nicest? Second one, probably. Okay, so X was -4 minus 2Y. I don't know what Y is. Z was, and I instantly forgot what Z was. -6, that's right. Okay, but look, I'm going to do minus -6. So it's going to be +6, right? So +6 equals 2. I can combine the constants. -4 and 6 is 2, so I have -2y plus 2 equals 2. Subtract 2. -2y equals 0. Okay, so what's y? Well, we divide by -2, right? What's 0 divided by -2? 0. If I have nothing, I divide it as many times as I want to, it's still going to be nothing. Okay, so y is 0. Okay, here's our ordered triple. Here we go. Ordered triple. X, Y, Z. Solution is equal to X, -4. Y, 0. Z, -6. That little tiny ball in space where there's 3 tiny zeros. There you go. Do you not feel like a genius? I mean, look at your paper right now. Just like look at it. Do you feel pretty smart? It's not that it's hard. It's just long, right? Can we agree on that? Okay. Not everything you do in this class is going to be this long. Okay. All right. We have one more that we're going to set up. We're not going to solve it. We're going to set it up because it's a word problem. When you get in tomorrow, we're going to break. We're going to break up into little groups, and we'll let you solve it all over these desks, right? And we'll take pictures of it. All right. But all I want you to do right now is set it up. Would you like me to read it to you, or would you rather read it to yourself?
Just reading.
All right. At the
art.
arcade, 3 friends are playing games at the arcade. We have Sammy, who has won 2 blue tickets, 1 yellow ticket, and 3 red tickets, for a total of 1,500 points. All right, so I guess the tickets are points, right? Okay. Jamal won 1 blue ticket, 2 yellow tickets, and 2 red tickets for a total of 1,225 points. Yvonne won 2 blue tickets, 3 yellow tickets, and 1 red ticket for a total of 1,200 total points. Write a system of equations to determine the point value of each type of ticket. I'm going to let you write the system, but I would like for all of us to come up with the same variables. Because if you notice, they did not define variables for us, and someone has to do it, either the problem author or us, right? Okay, so what is it we're trying to find here? It's not quite how many tickets, though.
Value.
The point value, right? I haven't been in an arcade. I don't know that this is a thing. Okay, but apparently there are colored tickets that have different amount of points in them. Is that how it goes? I guess. I don't know. Okay, but apparently that's how this is. So it's not the number of tickets, because we know how many tickets they have. It's the point value. So we're going to let, all right, well, we got colors, right? What's the first color they tell us about? Do they all go in the same order? Blue, yellow, red, blue. Okay. How about B equal the value of a blue ticket. Y equal value, you know what? I'm gonna do this. Y'all know that notation? When you do that, it means like mimic right above it, so you don't have to write it again. What's the rest? R equal value of a red ticket. Alright, now I want you to write down the system, which means the 3 equations that are described here. So, 1 equation for Sammy, 1 for Jamal, and 1 for Yvonne. When you think you have it, let me know. I'll check and see that you're right. And then we're ready for tomorrow. Oh, you guys already. Good. What? The last number. The last number. Yeah, that's right. All right. And you could even be thinking about, okay, what is going to be my method to solve it? If I were to solve it tomorrow, what would I get rid of? Okay. Good. I like how you didn't keep a 1 there. Yeah. Okay. Good. That's right. Translating from English into math.